You roll the dice. What's the chance that you will actually get your wish? And the first die will be a 6, and you roll again, and the second will also be again a 6. 3% chance. Very low probability. So you can count on not getting it. What if it does actually happen, that you get it twice in a row? Well, I don't know what that means. Well, think about that. Now, what about you want to have it 3 times in a row to get a 6. So you multiply the probability of 1/6 by 1 times 1/6 times 1/6. 1 out of 2 is 16. That's a 0.5% chance. Do not ever expect this. It is very unlikely that this would ever happen. So think about it. Think about this. Suppose a person correctly predicts a dice throw twice in a row. He says, I know I'm going to get a 6. Twice. You throw the dice once, it's a 6. Throw it the second time, it's a 6. Okay, what do you think? Is this unusual? Or is this normal? It could happen. Maybe you're thinking, it could happen. What if he says, I know I want it to be 3 6s in a row. I predict it will get a 6 3 times in a row. You throw the dice once, it's a 6. Second time, it's a 6. A third time, it's also a 6. I bet now you're starting to suspect something. I bet now you're starting to think, this dice is loaded. It's not random. The reason it's getting a 6 is because something's driving it to be a 6. It's loaded. It's designed to only fall out on the 6s. After all, it's only a 0.5% chance you got it right. You're that one person? Very unlikely. But some people are thinking, well, it could possibly happen, so I trust him. What if it goes 4 times? It's extremely, extremely unlikely. At that point, the probability is so low that even someone who's extremely trusting would say, no, it makes no sense to say that it was just randomly like that. That dice is loaded. You see how you can combine probabilities to show how something is extremely improbable. It's the same thing with class evidence. You combine 2 bits of class evidence that shows something is not probable or something is probable, and combined with another thing that shows that shows the probability. You multiply the 2 and you'll actually get some number that you can use. Here's an example. When we combine class evidence, we combine the probabilities. Okay, we find at a crime scene, whatever it might be, a burglary, a murder, who knows. Someone got into someone else's house, either burglary, homicide, whatever, and we find someone who was suspected, a person of interest, a POI. We suspect this person did it for who knows what reasons, and we find them, and we find evidence were bedspread fibers, and we find them on the suspect. We find that the getaway car that we know came for that, for whatever reason we know that he used this car to get away, it left a paint scraping on a wall. Okay, so we have the paint, at least the outer layer of paint of the criminal's car. And we also have tire tread impressions from tires that we know came from the getaway car, the criminal's car. And we find all 3 of them in the possession or in the control of the suspect. The suspect's car, has the same kind of paint job. The suspect's tire treads are the same width and the same kind of impression, same kind of design, like jagged, whatever tire tread impressions look like. And we find the bedspread fibers on him. Okay, so what are the chances that bedspread fibers are found in a suspect? Let's give it a ballpark figure. 1 out of 100 people had the same kind of carpet. So this guy, this suspect might have been rolling around on his neighbor's carpet, and he picked up these fibers, but it had nothing to do. He was never at the crime scene, never did anything, never hurt the victim at all. Okay, that says 100% chance. Again, could be. You might think that's reasonable enough. You can't blame him. Can't say that he's guilty just because you find the bedspread fibers. It could be he was at someone else's house and picked them up. The paint scrapings, let's say there's a 100 chance. Again, just a ballpark figure, 100 chance that his car was just painted the same paint job as the real criminal's car. And furthermore, there's tires that he didn't do it. His tire tracks, the tires from his car, were the same pattern and width of whatever the criminal's car had, or the tire tracks from the criminal's car. So suppose you have all these things together. Now, here's what the defense lawyer is going to say about this. Okay, so look, bedspreads, who knows? A lot of people buy the same bedspreads, so you can't blame him just because he happened to have the same bedspread fibers. So what? He was jumping on somebody else's bed and they had the same fibers. Who knows? Doesn't prove a thing. And as far as the cars with the paint job, a lot of people have the same paint job, not just the person you're suspecting. So it wasn't him; it was somebody else. Somebody else could have had the same paint job. And what about the wheel pattern? The tire tracks, the tire impressions. A lot of people buy the same kind of wheels. So why do you suspect my client? That's what the lawyer's going to say. Why do you suspect him? A lot of people have the same bedspreads or cars or car tires or paint jobs. You can't blame him. That's their defense. But what's the response to that? How likely is it that there is one person that had the same fibers and the same paint job on his car and the same tires, but wasn't actually there? What we do is we multiply the probabilities together. Okay, the bedspread fibers, we were saying a ballpark figure is 1 out of 100. Okay, could be. Like let's say, I can understand that if you'd say that you found somebody, the only evidence you had was he hadn't had the same bedspread fibers. He can certainly claim, look, I was at a bunch of people's houses and I picked up some bedspread fibers. It's not me. I wasn't in the crime scene. I'm not guilty. You can argue with that. You can make that argument. That is somewhat reasonable. But would he also have the paint scrapings? What's the odds? If this is 1 out of 100, you multiply that by 1 out of 100, there's a 1 out of 10,000 of a chance. You multiply that by the tire tracks, where there's another 1 out of 100, that's roughly 1 in a million. Okay, that is 1 in a million. So it's a 1 in a million chance that this guy is actually innocent. Okay? Or that he wasn't at the crime scene. So what does that tell you? 1 in a million? You don't believe it. This guy was at the crime scene, and it was his car. He drove to the car. He drove with his car. He left the tire tracks, scraped the wall, scraped the paint off the wall. And he did the crime, and he accidentally brushed against the bedspread. That's what happened. It's not that someone else did everything. The odds, by putting all these things together, and by getting whatever it is, by multiplying the probabilities together, we realize there is a 1 in a million chance that it was somebody else, and something like a 999,999 chance that he was the one. It's a little bit this is a little bit more simple than it actually is, but that's basically the way the probability works, and that's why you want to talk to a jury. You can certainly convince them that it's very, very unlikely that all these coincidences happen to the same person. What's more probable is he did it. It's not a case of probability. It's a case of certainty. He was there. He did it. So even though all these situations, all these things, the fibers, the paint scrapings, and the tire tracks are all class characteristics, class evidence, we can still use it